Hi, Dr. Bennett here. Today we're going to be talking about inductive and deductive reasoning, which are both good approaches to supporting your argument. We're always going to start out with an assertion or a claim, something that we want to convince someone of, and we need to have some way of backing that claim up, right? So we're going to start out with inductive reasoning. They're two very different approaches, and you'll have access to both as you make your own arguments. So consider both because they're both valuable. We tend to depend more on inductive reasoning in academics. However, I can imagine and have read many philosophy and maybe political philosophy articles and books that were based more in deductive reasoning. So I think for our papers in our class, you'll depend most heavily on inductive, but remember that deductive is a possibility for you. So with inductive reasoning, as you can see here on the sheet that I've come up with that features some examples, we might start with an assertion that says, over the last 5 years, the threat posed by E. coli in Lake Lanier has been reduced. So we're claiming that there's less E. coli, which is a harmful bacteria, that there's less in Lake Lanier than there used to be. How do we know that? Well, with inductive reasoning, it is mostly based on samples. We've experimented over and over again, and we've come up with enough results that we've been able to find a trend. We've been able to see a pattern. So evidence here might include this made-up study that I'm going to mention, that in a 2024 study, 322 out of 400 water samples that were collected from Lake Lanier at a wide variety of locations showed E. coli levels lower than samples that were taken in a 2019 study. So you're comparing the two and you're seeing the numbers show less now, right? There are other kinds of examples. So the next one's also based on a study, a very different sort of topic. Replacing sugary treats with nuts and fruits increases one's chances of losing unwanted pounds. How do I know this? Well, I'm basing it on a study, and this is a real study. In a 2020 study by Robert Thomas, Madeline Williams, Graham Smith, and Angel Chater, whereby sugary treats were put away out of sight and replaced by bowls of fruit and nuts, 46% of the participants lost weight over a 5-month period. Now, this is not even 50% of the participants, but in this case, we're comparing people who had nuts and fruits offered to them rather than sweets in bowls. We're comparing their behaviors and their weight loss to a group where the sugary treats were in the room. So in that case, there would have been less than 46% who lost weight, right? So you're more likely to lose weight if you have the fruit and nuts sitting in front of you than the sweets in front of you. Doesn't mean 100% of the people are going to lose weight, but it's just comparing the statistics, right? And with those kinds of samples, one thing you're going to assume, and you need to think about this moving forward as you evaluate studies that you read, you want to make sure that if that study was repeated again by someone else in possibly a different environment or maybe the same environment, that they would get the same results. So if the sample's too small, like let's say somebody went out and got one sample of water from Lake Lanier and tested it in a solution in a lab, that's not enough of a sample of Lake Lanier to be able to say that overall E. coli is at a particular level, right? You might go to another spot on Lake Lanier and it might be really high. So you've got to get it, you've got to sample it from a variety of different locations to be able to say that Lake Lanier in general has lower E. coli. Similarly, in the second study, these sugary treats, it might have worked once in this study, that the people with fruit and nuts, lost some weight more than the people that had sugary treats sitting out. But what if you took the same study into, let's say, um, a sixth grade classroom? Would you get the same results? So this was actually done in a hospital, and it was a bunch of nurses who were walking around, and there was a bowl of fruit and nuts on the counter that they were passing by. What if you had more men than women, or more women than men? So the one thing we want to do when we're testing data is to make sure that it's going to be consistent enough in a variety of circumstances that what you're claiming is going to continue to be true. Sometimes it's easy to skew the results of a study because you're sampling a specific group. So for example, because these were nurses, it's possible that because they were being experimented on, that they just, decided, well, I'm going to try to lose weight over the next 5 months because when they test us at the end, I don't want to have gained weight. Maybe nurses would have a particular attitude toward the study. So it can be skewed, but regardless, inductive reasoning reaches out and tries to find some kind of observations or data to support whatever assertions are being made. I'm going to give you an example here. The third example is not done by an official study. So we use inductive reasoning all the time in our own lives. Here's an example of something I might claim. Since my budget is tight this month, I'm going to do my grocery shopping at Walmart rather than Publix this week or this month. How do I know that it's going to save me money to go to Walmart? How do I know that? Well, I'm just a human being and I'm always observing, right? And I'm sort of collecting data. So we all have assumptions about things that we have formed ourselves based on our own observations and kind of informal tests, right? So here's the evidence that I might claim, and I'm making this up, okay? I didn't actually write down, the prices when I was shopping. Evidence that Walmart items are cheaper on average than the same items at Publix, okay? So they have to be exactly the same items. I observed over a 6-month period of shopping at both stores that staples of specific brands, such as Fairlife milk, Pepperidge Farm bread, and Purdue chicken breasts, were consistently less expensive at Walmart than at Publix. So again, I have to compare apples to apples and even types of apples, right? I might need to say, okay, Honeycrisp apples are cheaper per pound at Walmart than they are at Kroger. Not, Gala apples are cheap at Walmart, and then I go buy Honeycrisp at Kroger and they're more expensive. So you got to be comparing not just apples to apples, but also types of apples to the same types of apples. Anyway, the point is we're using data to support our assertion. Okay, let's talk about what deductive reasoning is then. And I often think about Sherlock Holmes when I'm thinking about deductive reasoning, because this is how he does things. And this is how I remember the difference, because I used to get them backwards a lot. So I started thinking about how he always deduces based on some facts that he already knows. He kind of builds an equation. So here's an example. If you don't want to be, so let's say I've got a guest over at my house and I have a cat named Xena, and my guest is maybe even allergic to cats, okay? So I'm telling my guest, if you don't want to be disturbed by my cat Xena tonight, you should close the guest room door. Now, how do I know that Xena will go in there and bother my friend? Well, here's the first fact. Cats are nocturnal and they're most active at night. If that's true, and the second thing is true, which is that Xena is a cat, then the third thing is very likely to be true as well, that Xena will be inclined to explore your room tonight unless you take precautions and close the door. Okay, here's another example. I'm sure my mom would rather vacation in New Mexico than in Florida. How do I know that? I mean, this is her preferences, right? Not mine. Well, the first fact that I'm considering, if I were Sherlock Holmes, would be that West Texans tend to prefer arid climates. My mom is from West Texas. Second factor of the equation, New Mexico has an arid climate, while Florida has a very humid one. So my deduction is my mother, who lived most of her life in West Texas, would prefer to vacation in the dry climate of New Mexico. Okay, let's look at one that's a little more pertinent to what we might be doing in class. Prison inmates need to access high school GED classes. I'm going to make this claim so that they can more successfully reintegrate into society after release. How do you know that that would help? Here's the first fact. A high percentage of prison inmates did not obtain a high school diploma before they were incarcerated. So we know that there are a lot of people who don't have a GED already or a diploma. Second fact, people with a high school diploma have a higher likelihood of securing a job out in the world, which is an important factor in successful reintegration. So if the first fact is true and the second fact is true, then the third part of this equation is likely true as well, which is that inmates who can earn a high school diploma while in prison can decrease their chances of returning to prison after release. So I hope you can see the differences between these two types of reasoning. Even though we're talking about percentages here in this third one, this is not based on a study, right? We're not presenting a study to show you that inmates need to access to GED classes. Instead, we're just stating something that everybody already knows, which is that there is a gap for inmates in their educations for the most part. I mean, there are inmates in prisons who already have a high school diploma. However, education, we kind of presume that I, as well as my reader or my listener, share the assumption that education is one of the problems facing inmates. That's one reason maybe they're in jail in the first place, is that they have a high illiteracy rates, or that they have a high school dropout rate. That more people who drop out of high school are going to end up in prison, for example. So that's not something I have to go do a study on for you to believe me. You already know that, right? Even if you've never read a study about it, we just know that. Secondly, we know that people with a high school diploma have a higher likelihood of getting a job. So those are two things that we already can assume. And so that now we can build a third truth out of those. So this is like an equation. It's kind of like if you said, if you were writing a computer program and you said, all redheads can have free tuition. Julie is a redhead, therefore Julie gets free tuition. So if she's typing in her application and they ask her what color hair she has, she says red, and the computer shunts her over down a particular path only for redheads, right? That's kind of how deductive reasoning works. If I say something like only people 18 years and older can access this website. Are you 18 years older or older? Yes or no. If you say no, then you can't, it just shuts you off from the website. If you say yes, now you're allowed to come into the website. So it's basically an equation, a logic equation. But going back to the inductive reasoning, if you notice, these are things that we are still researching. Just because, for example, we did the one study of people eating nuts and fruits over sugary treats, we understand that that is the kind of experiment that's going to need to be repeated over and over again. And even after we see these results, we're still going to maybe have studies from time to time that contradict these results, that say, strangely, those people ate a lot of sugar, that they still ended up losing weight. So we're going to have to kind of keep refining it. Okay, so you will have access to both types of reasoning as you write your papers. Just consider how you might use some of both to help persuade your reader. All right, thank you. Bye.